Hello everyone, I am Usna Bagalkot from 5th Sem AML department. Today I will be explaining about an epsilon NFA, that is epsilon non-deterministic finite automata. To begin, we must answer a few fundamental questions. What exactly an epsilon NFA is? In standard finite automata, transition happens only when an input symbol is read. However, an epsilon NFA differs because it allows epsilon transition also. This means the machine can change its states without consuming any input symbol. Let's understand this with a practical example. Please look at the diagram on the screen. We have three states Q0, Q1 and Q2, and the transition include the standard input like A, B and the C. You see the transition marked with the epsilon moving from Q0 to Q1 and Q1 to Q2. This means the machine is in the Q0. It can simultaneously move to Q1 or Q2 without reading any input. Because of this multiple possible moves, the machine is a non-deterministic. Before we can convert this into a standard NFA, we must calculate epsilon closure. Formally, the epsilon closure of an state Q is the set of all states reachable from Q by taking 0 or more epsilon transition. Based on our diagram, let's calculate them. Epsilon closure of a Q0 is from Q0 we can go to Q1 via epsilon, and from Q1 we can go to Q2. So the closure of a Q0 is Q0, Q1 and Q2. Next, epsilon closure of Q1. From Q1 we can go to Q2. So the closure is Q1 and Q2. For the epsilon closure of Q2, there is no outgoing epsilon moves. So it is just Q2 only. So it describes how epsilon closure helps determine reachable states during computation without epsilon moves. To do this, we use the formula where a new transition delta of Q, X is the epsilon closure of the state reachable on input. Here is the solution based on our previous closure calculation. First, we are in a current state Q0 and we are taking input symbol as A, and the next state is Q0 or Q1. By taking the input symbol A, the Q0 state is moving to Q0 and Q1. So it can be represented as delta of Q0, A equals to Q0, Q1. By taking the next input symbol B, the Q0 is moving to Q2. So the transition will be delta of Q0, B equals to Q2. Then the current state Q0, by taking the input symbol C, it is not moving to anywhere. So we don't have any transition for this. That's why we have wrote here 5. So the transition will be not there. By taking epsilon as an input symbol, the Q0 state is moving towards Q1 and Q2. So the transition for this is Q0 delta of Q0, epsilon equals to Q1, Q2. Same for the Q1 state and Q2 state. So by taking from the Q1 state, by taking input symbol, there is no transition. Next step, it is not taking A as an input symbol, so we have wrote 5 here. So next, by taking the input symbol B, the machine is moving towards Q1 and Q2. Q1 and Q2. So the transitions are delta of Q1, B equals to Q1, Q2. Then by taking C, it is not moving anywhere. So it is delta of Q, C equals to 5. By taking epsilon transition, it is moving to Q2. So delta of Q1, epsilon equals to Q2. For the next state Q2, by taking the input symbol A, it is not moving anywhere, so we have not having any transitions. Next for B, it is not moving anywhere, so we don't have any transitions. By taking the input symbol C, it is having self loop and transition, so we have wrote delta of Q2 comma C equals to Q2. Next for epsilon also, it is not having any transitions, so it is phi. To wrap up the theoretical aspects, we define epsilon and